Welcome all. In last lecture we have seen the 7 segment display and BCD to 7 segment decoder design. In today's lecture we are going to see BCD to 7 segment decoder IC study, and after that we are going to see what is a Tristate logic and Tristate buffers. First we will see the BCD to 7 segment decoder IC study. The IC number for BCD to 7 segment decoder IC is 7446 7447. This is the pin configuration of IC 7446 or 7447. This is a 16 pin IC starting from 1 to 8 and 9 to 16. This IC pin description is given in this table, where this is a BCD to 7 segment decoder IC. So the BCD inputs are A0, A1, A2, A3, which are connected to pin number 1, 2, 6 and 7. These are the BCD inputs. A0 to A bar to AG bar, these are the active low output pins. That is, these pins are going to be connected to the 7 segment display. That is pin number 13, 12, 11, 10, 9, 14, 15. These are the 7 outputs of this IC. Pin number 8 and 16 are connected to the power supply. Now there are 4 pins. The first one is LT bar pin, that is lamp test pin. This pin is used to check whether all the segments of display are working properly or not. If LT bar is forced low, then all the output terminal will be forced to their active state, that is low. If display is connected, then all its segment will glow simultaneously if LT bar is low. Whereas if LT bar is 1, then all the segments of the 7 segment display will be in a off state. So by connecting 0 or 1, we can check whether each segment of the 7 segment display is in working condition or not. After that, the next pin is ripple blanking input pin. This is also active low input pin. If RBI pin is 0, then it switches off the display when BCD inputs are correspond to 0. Means if RBI is connected to 0, for blanking out the leading zeros in the multi-digit displays. That means if the number 98 is to be displayed with a 4-digit display, then 0098 will not be displayed. The two leading zeros, these are the two leading zeros, will be blanked and the display will be only of 98, even though the display is of 4 digits. So this is how a RBI bar pin can be used to blank the leading zeros which are not necessary to display a particular number. Next is the blanking input pin. This is also active low input pin. If it is connected to 0, then the display will be switched off irrespective of the BCD input. This feature is used in the multiplex display in order to save the power. After that, The next pin is RB O bar pin, that is ripple blanking output pin. This output is normally connected to logic 1, but as it goes to logic 0, then it is used for cascading purposes when multiple decoders are used. Now next we will see how a 7447 IC is interfaced with the 7 segment display. The common anode point and blanking input pin, ripple blanking output pin, ripple blanking input pin and lamp test pins are connected to positive supply permanently. To make BI, RBO, RBI and LT bar pins inactive, they are connected to plus 5 volt supply. The BCD inputs are applied to the inputs A3 to A0 pins. These are the output pins of the ICs which are connected to the 7 segments of the 7 segment display. External resistance of value R is connected in series with each segment to limit the maximum current. This is how we can interface the IC 7447 and 7 segment display. Now we will see what is a Tristate logic. We have discussed the totem pole and open collector output TTL configuration in the second unit. Now we will see the third type of output circuitry used in TTL as well as CMOS logic families, which is called as a Tristate logic. It is called Tristate because it allows 3 possible output states, namely high, low and high impedance state. We will see one by one. An additional input called output enable has been introduced. Both pull up and pull down transistors are used. The output enable pin decides the operation of transistors Q3 and Q4. This is the diagram for high state, in which OE bar pin is connected to 1. Means OE bar pin is now inactive as it is a active low input pin. So when OE is 1, then whatever input we have applied, it will be inverted at the output side. Means this circuitry is going to act as an inverter actually. So as OE bar is inactive, whatever input we give, inverted output of that input we will get at the output terminal. So this is how we can get a high state by applying a low input and by connecting OE bar pin to the logic 1. Next we will see a low state, that is at the output we will get a logic 0. In this also OE bar pin is connected to logic 1 so that input can occur at the output side. So to get low state we are going to apply a high input, and as this circuitry is going to operate as an inverter, then we will get a low output at the output terminal. Now next is the high impedance state, in which OE bar pin is 0. Means input cannot reach to the circuitry. There, that is, whether you apply a logic 1 or a logic 0, it will not reach to the transistors, by which both the transistor will remain off. So output will not be connected to either plus VCC or it will be connected to the ground. So we cannot predict the state of the output, either it is in a high state or either it is in a low state. Therefore Such a state is known as a high impedance state, in which output neither be 0 and nor it will be a 1. So these are the three states: high state, low state and high impedance state. Now next we will see a tristate buffers. It is a circuit which either connects or isolates its input from its output. In other words, it controls the flow of signal from input to the output. Tristate buffers are of two types, namely non-inverting buffers and inverting buffers. The inverting tristate buffers will invert the input data while passing it to the output. This diagram is for non-inverting buffer, which shows the symbol and truth table. This is a buffer, symbol of buffer, input terminal and output terminal. The input will pass to the output based on the status of this enable terminal. For this, the enable terminal is a active low terminal, means when it is 0, we will get output as a, means for active low input it is a 0, so input can be connected to output. Now if enable terminal is 1 for this case, then it will not enable input to appear over the output terminal. In that case we can say the output is in high impedance state. We cannot predict the state of the output. In this, enable terminal is active high terminal, means if it is 1, then only the input can appear over the output line. If it is 0, then we cannot say, then input is not connected to output, therefore we cannot say output is either 0 or 1. This is how the buffer works. The octal tristate buffer, line driver, line receiver IC. Next we are going to study this IC. This is IC in which buffers are used. These buffer line drivers are designed to improve the performance and PC board density of the tristate buffers. The IC is an octal tristate unidirectional buffer. It consists of 8 unidirectional buffers as shown in the pin configuration. The IC is a 20 pin IC. The pins labeled 1A1, 1A4 and 2A1 to 2A4 act as 8 input lines of the 8 buffers, whereas the pin labeled as 1Y1 to 1Y4 and 2Y1 to 2Y4 are the corresponding output lines. The 1 OE bar and 2 OE bar are the active low output enable inputs. If these lines are at logic high level, then all the outputs go into high impedance state as shown in this truth table. The 8-bit IC can functionally split into two 4-bit sections so that they could be operated together or separately to drive one 8-bit bus or two separate 8-bit buses. Similarly, the next tristate buffer IC is 74245. This is a bidirectional buffer IC, means the data can be flow in either directions. The functional table is shown over here. Based on the pin G, it can operate in two-way direction. When G bar pin is low and direction pin is low, then data can pass from B line to A line or B bus to A bus. When enable bar pin is low, direction pin is high, then data can flow from A bus to B bus. This is how the data can flow in a two direction. And when enable bar pin is high, then no data will flow from either direction, even though whatever be the status of the direction pin. Means it creates isolation in between the two buses. This will be the end of unit 3. Thank you.